Okay, so can you all look at page 18, please? Because sometimes what you're asked to consider in a reaction is not on your electrochemical series. So it might be something else. And you might have to be carefully looking at the information in the question to see if it's on here. Because if it's on here, you don't need to work it out. You can just copy it off the electrochemical series. But if it's not on here, then you will have to work out the half equation for it. When you are in a situation where you need to work out the half equation, you will be given the reactant and the product. Okay, you won't have to guess the product. But in our example, we're going to look at, well, how would we go about balancing a half equation for our permanganate ion, and I've written down the name just because it's going to be an important one for you to know and recognise as we go on. What happens if we then undergo a reaction to form the manganese ion? Well, there's a few steps involved in balancing our half equations. The first thing we do, okay, so step one, is we balance everything that's not hydrogen or oxygen. And in this case, it's the manganese, and there's the same number on either side, so it's already balanced. So that's done in this particular example. But it's one to be careful of, one that trips students up sometimes. The second thing we're going to do is balance with, we're going to balance oxygen with water. So if I look at this reaction, I have 4 oxygens on my reactant side and I've got none on my product side. So that means I'm going to need 4 waters to get those 4 oxygens on the right-hand side of the arrow. Yeah? It's a dodgy looking too. Now we're going to balance hydrogen with acid, H+ ions. So now I've got 8 hydrogens on my reactant side, and none on my product side, and none on my reactant side. So I need 8 H+ ions on this side. And then we're going to balance charge with electrons. And this might be the place where some people get a bit confused. So if I look at this, I'm just counting charge on each side. What I have here is -1 plus 8 is going to equal 7, isn't it? So that's +7. And on this side, well, I only have one charged species, that's the manganese ion, which is +2. The only thing I have available to me to balance the charge is electrons, and they have a negative charge. So I need to subtract 5 from this side to make it equal to 2, don't I? Which means I'm going to add 5 electrons to that side. Because if I have -5, -1, plus 8 equals 2. And this one equals 2. And so they equal the same plus 2. Yeah? Do you see how that they equal each other in charge now? The 5 electrons, the permanganate ion, and the H plus ions, we all end up with plus 2 on the reactant side to match the product side. And so now, I've made that aqueous and that should be liquid. Is this an oxidation or a reduction half equation? This is a reduction half equation. Why?
Because it
Yeah. The electrons are on the left-hand side. That's right. Let's have a look at another one. So if we look at example 2, we're asked to balance the oxidation half equation where we've got the bromide ion. Okay, so we're looking firstly everything that's not hydrogen or oxygen. I've only got one bromine on either side, so that's fine. Then I need to balance the oxygens with water. I've got 3 oxygens on this side and none on this side. I'm going to need 3 waters over here to balance the oxygens. Then I need to balance the hydrogens. I've got 6 hydrogens on this side. So I need 6 hydrogen ions on my product side. Now if I look at the charge, this is just -1 on that side. I have -1 plus 6 will equal 5. So that's a positive 5. And remember, the only thing I can balance with is electrons that are negative, and I need them both to equal the same. So I'm going to need to add the electrons to this side, and I'm going to need to add 6, aren't I? Because plus 5 minus 6 equals -1. Does that make sense? Okay. So you can now go on to question 18. Doing the same thing. And like I said, keep your eye out for anything that, for example, H, the very last one there, if you've got the S2O3, 2 minus, going to S, what's the first thing we need to do? Yes. Yep.